Hello everyone, welcome to the solution of LeetCode problem 46 named Permutations. In this problem, we are given an integer array of distinct integers and we have to return all possible permutation of this array. And luckily, we can return the answer in any order. In the example 1, the array contains 3 elements, which is 1, 2, and 3, and it has 6 permutations, which are 1, 2, 3, 1, 3, 2, and so on. For the example 2, the input contains 2 elements of vector and the permutations are 0, 1 and 1, 0. For the third test case, there are only one permutation of the vector containing just one values, which is 1. So I hope you understood the problem. Now let's move on to the constraint. Here, the array length can be in between 1 to 6, and each of the array element can be in between -10 to +10. And it is ensured that all of the array elements are unique. I hope you understood the problem. Now let's move on to the intuitive approach to solve this problem. Anyways, in the first test case, the vector contains only 3 elements, which are 1, 2, and 3. And we have to find all possible permutation of this vector. For this, we have to use the backtracking approach to solve this problem. Here, we will generate a decision tree and try to reach the optimal solution after completion of the generation of decision tree. Anyways, let's move on to the discussion. At first, our input contains 3 elements, which is 1, 2, and 3. Now, suppose we have ignored element 1. So we have element 2 or 3 right now. Now, at first our problem was our given input contains 3 elements, which is 1, 2, 3, and we have to find all possible permutation of this input. But now our problem reduced into our input array contains 2 elements, which is 2 and 3, and we have to find the all possible permutation of the input 2 and 3. So there is an actual sub-problem exist. Anyways, I hope you understood the concept behind the sub-problems. Now let's move on to the further exploration of this tree. So now, if we ignore the value 2, our vector will contain only the value 3, which is this. Now we have reached the base condition because for the vector containing only one element 3, this is the only possible permutation of this vector. So we don't have to further explore any other things from here. Now we have to get back to the caller node or the parent. And now, as we ignore the value 2, so we have to append the value 2 from the end of the list here. Now again, suppose we ignore the value 3 here. So we have to explore the vector which contains only value 2. Anyways, we have reached another base condition. We don't have to further explore anything from the node 2 or the vector 2. So we have to get back to the caller node. Now, for the first returning, at first we have returned the value 3 and we have append the value 2 at the last of the vector. And for the second returning, we are returning the value 2 and at last we have to append the value 3 into the last of the vector because we have ignored the value 3 while exploring this path. Anyways, our vector now contains 2 and 3. Now we have explored all of the subtree of this node, and we have to return from this node as well. So we are returning to the root of the tree. In the root, we have firstly ignored the value 1, and now we are appending the value 1 at the last of the vector. So we also have to append the value 1 into the result. So far, so good. We have reached 2 permutations of the vector containing only value 1, 2, and 3, which are 2, 3, 1 and 3, 2, 1. Anyways, now we have to try find other permutation as well. I hope you understood the approach of finding the first two permutations. The logic for the rest of the permutation are actually same. Anyways, I am explaining it right now. Now, we have to ignore the value 2 and our resultant vector will contain the value of 3 and 1. Now for this 3 and 1, we are ignoring the value 3 and our resultant vector will contain only the value 1. So it is one of the base condition. We don't have to explore any other subtree from this one. So from this we are returning. And as we ignore the value 3 here, so we have to append the value 3 at the last of the list. Now our list contains the value of 1 and 3. Again, we are ignoring the value 1 here. So our vector contains only the element 3. So we are writing down 3 here. We don't have to further explore any other things because from the node 3, we have reached the base condition. So we are returning from the 3 here. And now, as we ignore the value 1, before exploring this path, we have to append the value 1 at the last of the vector. So we are appending 1 here. Now, our vector contains only two elements, which is 3 and 1. So now we have explored all of the subtree in this position. So we have to return from this here as well. But as we ignore the element 2 before exploring the subtree, we have to append the element 2 at the last of the vector here. And also we have to append 2 here and here as well. So now we have find another two permutation of this vector, which is 1, 3, 2 and 3, 1, 2. Now we have to ignore the value 3 here, and for this path, our vector contains only two elements, which is 1 and 2. And now from 1 and 2, we have to ignore the value 1. So our vector will contain only the value 2. So we have reached one of the base condition because we cannot explore any other subtree from this vector 2. So from this, we have to return to the caller node. And as we ignored the value 1 before exploring the path, we have to insert the value 1 at the last of the vector or list. So now we have found 2 and 1. Anyways, now we have to ignore the value of 2. So our vector will only contain the value 1. And we have reached another base condition. We don't have to further explore any of the tree from the node 1 or from the vector 1. So we have to return from here to the caller node. And as we ignore 2, we have to append 2 at the last of the vector. So now our vector will contain the value 1 and 2. And as we explore all of the subtree in this position, we have to return from here as well to the root. And as for the root, we have ignored the value 3. We have to append the value 3 at the last of the vector. So we are appending 3 here and here as well. Now we have seen that we have found 6 permutation of the vector containing 3 elements, which are 1, 2, and 3. I hope you understood the working procedure of this decision tree or this backtracking algorithm. Now let's move on to the actual code. In this code, we are given a function named permute, and the parameter of this function is a vector, and we have to return a list of vector after completion of this function. Now we have to declare a vector result to store all possible permutation of this input array, and we have to recursively call a backtracking function. For the sake of simplicity, the name of this function I consider is f, which has three parameters. At first, the input array. Second, the starting position of this backtracking algorithm, which is 0. And at last, the resultant vector, which contains the list of all possible permutation. Anyways, from this, let's try to understand the working procedure of the backtracking function. At first, our backtracking function will check whether our starting position is equal to the last position of the current input array. If it is, we have to append the input array to the result and return it. Otherwise, we have to use a loop which will run from the starting position to the end of the input array. And in each iteration, we have to swap the value presented in the start index and the ith index. Here, the swapping is the actual ignoring, which we already explored in the decision tree algorithm. Now, after swapping, we have to recursively call the backtracking function from the next element, which is start plus 1. And after exploring the backtracking algorithm from the next element, we have to again get back to the original position of the input array. So we also have to swap the value presented at start index and the ith index, because if we swap two value position in the different index 2 times, their relative position will remain same. So that's why we have to perform the swap operation second time. And finally, we have to return the vector result. I hope you understood the code. Now let's get back into the time and space complexity of this program. Here, for this algorithm, the time complexity is big O of n factorial, because in the first input, we have given 3 elements in the vector, which is 1, 2, and 3. And while exploring all of the permutations, for the first position, we have 3 choices. Either I can take 1, 2, or 3. So for the first position, there are 3 choices. And after choosing one element in the first index, for the second element, we have only 2 choices. And after selecting first 2 elements, for the last index, we have only 1 choice. And the total choice are 3 times 2 times 1, which is 6. So this is the result of 3 factorial, where 3 is the size of the vector. So we can say that the time complexity of this algorithm is big O of n factorial, where n is the size of the input vector. And the space complexity will also become big O of n factorial, because for our resulting vector, it will contains n factorial vectors as well. So we can say that the space complexity of this algorithm is also big O of n factorial. I hope you understood the time and space complexity of this algorithm. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.